Hello, hello. Welcome one, welcome all. Back at it again with some LeetCode. Been doing this now. Today's gonna be my sixth day, or actually it might be my fifth because I did two on the first day, so it doesn't necessarily go by the stream. But this is my sixth day doing these streams for LeetCode. If you have followed along with me, then we are around. This number is not completely accurate because I did some that I want to talk about now at the beginning of the stream. We should be around 30 problems. So again, if you've never done LeetCode before, you're looking for a place to start, this is exactly what the stream is aiming to do. I know, just like everyone else in this industry, it's hard to get into LeetCode, and so I'm trying to be sort of like an accountability buddy for anyone that's interested in getting into the grind, because I also realize that it's very hard to do so. And what I have done is on my YouTube channel here, I go ahead and I've been uploading all these different videos, all these streams that I've made, I've been uploading them. And if you look right here, it says LeetCode Accountability Stream number 1, start here. And what I do is for each one of these streams, you'll see a list of questions that we've worked on. I link to all the different questions that we've worked on, so you can approach this in a couple different ways, right? You can either you can either do all the questions and then watch the stream afterward, or you can watch the stream as you're doing the questions. And again, it's for accountability. You watch the stream, you finish the video, and all of a sudden you've done more problems than you probably could have done on your own, because I've been there and I know it's hard, especially if you're just trying to do it on your own. So hopefully by watching the streams, you'll learn a thing or two. I'm also very open to hearing what everyone else has to say. So if you have some, that you want to tell me, chime in, maybe something that I could be doing to better improve my skills, I'm more than happy you know, to change my ways, I guess. I'm very flexible. So with that being said, we're gonna go ahead and start. I think this stream today will be around an hour. Normally I try to do an hour around an hour. I think any longer, unless maybe if it's like the weekend, I'll do longer, but on the weekdays, I think it's nice to do an hour. So we're gonna start. Again, I have been doing my goal is to do every single easy question, then every single medium, then every single hard. So I'm gonna start today with, we're gonna actually start with this. This one is so downvoted, it's incredible. It's called Design and Order Stream, and I've already done it, but I'm gonna reset it here and sort of give you my intuition on it. And again, we're doing this together. A lot of these problems I've seen, but also a lot of these problems I haven't. So expect mistakes to be made, and that's good. That's how we learn. So anyway, let's read this. There's a stream of n ID key value pairs arriving in an arbitrary order, where ID key is an integer between 1 and n, and value is a string. No two pairs have the same ID. Design a stream that returns the values in increasing order of their IDs by returning a chunk list of values after each insertion. The concatenation of all the chunks should result in a list of the sorted values. Implement the order stream class. So the constructor constructs the stream to take n values, and then it inserts the ID key and string value, enters the pair ID key value into the stream, then returns the largest possible chunk of currently inserted values that appear next in order. So this is a terrible question, as you can see. The like to dislike ratio is crazy skewed toward dislikes. So it's not like inconceivable that this one's not very high value, but in the spirit of doing all the questions, I'm gonna go ahead and do them. By the way, I realize that many of you are probably watching this on mobile. If you can, I highly recommend to try this out on your desktop. I tried to see if I can stream to mobile at the same time, but LeetCode's just not really meant for it. So if you really want to get on with it, then try to do the question with me as I'm doing it here on your own computer and really like type along with me. I'll put a link to the question I'm working on here to get us started. And also for anyone that's just getting into the stream now, I also do want to link to my YouTube. That way after this, you can watch the stream at your own pace, do the questions, and have a lot of fun doing that. Okay, so this is kind of weird, right? Like if we look at what's happening here, we have this pointer that looks like it increases anytime there's something new that's entered at the index that it's currently in, right? You can see like the pointer stayed while E was being inserted, but then as soon as D came along, it was inserted. Also stayed while A is inserted, we go to the next one. So pretty much like we're either gonna, there's like two different things here, right? Two different things that could happen. One, I guess the thing that drives it is if the ID key is equal to the current index, where that index is that pointer, or I'll say pointer just to match the animation. And then 2, if the ID key is not equal to the current pointer, right? So if the ID key is equal to the current pointer, there's 2 steps that we do here. 1, we're going to insert the new element, and then 2, as long as there are elements to the right, just to make this easier to read, the right of me, I will add them to my result, right? And now the second thing is if the ID key is not equal to the current pointer, we'll just go ahead and add the value at this index and return our result. Return result. Okay, so it looks like we need 2 things, right? We need this stream, and we also need this pointer. So I'll initialize these 2 variables up here. I'll say this.ptr for pointer is 0, and then this.stream is going to equal a new array of size n, and I'm going to fill it up with zeros because that's going to be how I know, because like all these things are strings, so I'm going to continue when I'm doing this sort of step right here. As long as there are no zeros, I can concatenate that to my final result. So let's see how we can do this. So we have 2 cases. If ID key -1, and I'm doing -1 because I think here, yeah, it goes from 1 less than or equal to ID less than or equal to nth, so it's like 1 indexed. So if ID key -1 is equal to this dot pointer, else, for each one of these, we're always going to have a result, and that's really going to be the thing that we return at the end. But it will change for each one of these, right? So if the ID key is not equal to the current pointer, then what we can do is we can say this dot stream at ID key -1 equals to value. And I believe that's all we need to do. Then we'll just return the result, which we never added anything to anyway. And now if ID key -1 is equal to this dot pointer, what can we do? So while this dot pointer, let's see, I think here a do while will be nice because we want to do this at least once while some other condition is true. So do while is like one of those what's that word, like the not the hero, but like some unhero or something. It's like something that we never use, but then when you need to use it, it comes like really in handy. Okay, so while this dot stream at this dot pointer is not equal to 0, and let me just move this so I have some more space, and this dot pointer is less than this dot stream dot length, right? We don't want to go out of the bounds here. I really wish I could make this a little, I might just like, can I not close this all the way? Okay, cool. So while this stream at this dot pointer is not equal to 0, so here we should be able to do result dot push this dot stream at this dot pointer, this dot stream at this dot pointer, and then we'll do this dot pointer plus plus. Now for both of these, we're always going to want to add. Let's think about this, because here, I guess we'll always want to add. I don't even think we need to do. I don't even think we need this else right here. I think we could just do this. So if result, we're going to add this. If ID key -1 is equal to this pointer, then while this dot stream dot this pointer is not equal to 0, and this dot pointer is less than stream dot length, we'll add the current thing that the pointer points to in the stream, and then we'll increment our pointer, and then we'll just return the result. So for the cases where the ID key is not equal to the pointer, we'll just end up returning this empty array, which is what we expect, and then, or else we'll get this sort of concatenated array with new values. So let's run this and see what we get. So it looks pretty good to me. I'm just going to go ahead and submit. I'll have to. Okay, cool. So this passed. Now this is like a very, I just feel like it's a very weird question. Something I think I did, like this helps me out a lot, right? So if you're ever in, it's easier to do when you're just at home practicing LeetCode, but definitely take the time to just plan things out. Like it took me less than 2 minutes to do this piece. So I think really like designing your algorithm, making these bullet points of the different cases and what you'll do will help guide you in your algorithm. And then you can end up with something that hopefully looks elegant and is less error prone or less but like less buggy. Because I mean, you might get a bug, but if you design it, then it should hopefully be easier to identify those issues where the bugs lie. So this really helped me for this question because the description and the animation made like no sense to me, but I'm happy with the solution, and we can sort of like talk about the time complexity here. So for space, I guess for the space complexity, like this result for each one of these insertions, how many times are we going to call insertion? Two, three, four, five. Is it always dictated by n? So for every insertion, I mean, worst case, is there ever a chance that we'll add, like this will grow to be the size of the input array the first time? I guess it really just depends on like result might be empty or it might be some amount of data, if that makes any sense. Where the worst case is probably the length of the array, and we'll do this n times. So like for every n times, we might have. So yeah, is it safe to say, saying it's like n squared, that doesn't seem right to me, because I think I'm calculating it for like the entirety of the algorithm, where maybe I should just look per call. Like per call, the space complexity of this thing is n, and the time complexity is also going to be n in the worst case. That's what I believe. Let's see the discussion here. Anyone has anything about, no one put anything about like time complexities, but I feel like it's linear on both time and space, but definitely open to hear what everyone else has to say. Okay, sweet. So let's do the next one, XOR array, XOR operation in array. I also did do this one before, but we can go through it now. So you are given an integer n and an integer start. Define an array nums where nums I equals start plus 2 times I and n equals nums.length. Return the bitwise XOR of all elements of num. So I think a really big takeaway here is try to do it without creating the array. I think if you create the array using this algorithm that they give you or using this expression, it's it'll certainly make the question a tad bit easier, but you can also do it in constant space, right? So it's kind of like think about a couple of different things here. Like we know we're always going to have n minus 1 operations, 0, 1, 2, 3, 4, right? So, and we're already given our start, which is 0. So really we want to start from the second thing and XOR it with the previous thing every single time. So what if we had something like let operations equals 1, because we're going to start at the first one anyway. We can have our XOR equals start, and then maybe next. I think next would be fine. Like our next, really, like our next is always going to be, since I is 0 for 1 and for the second one is 2, start plus 2, it's just going to be start plus 2. So I think what we can do here is we can say while operations less than n, we should be able to do, let's see, uh, next XOR equals next XOR, and then uh, next start plus 3 equals 2, 2 times 4. Now, are we always just going to, like, we'll get XOR is next and XOR, and then can we just increase the value of next? X equals next XOR, next XOR, and then do operations plus 1. Return XOR. Like, will this get us there? Let's see. It's funny because I did it earlier, but you know, you do one thing once and then you just like forget. 8 and 8, okay? 8 and 8, 8 and 8. So let's see. Now, this, oh, 100%. Wow. I feel like I've never gotten this before in JavaScript, so that's nice. I'm gonna take a snapshot of that, upload it to my Discord. Boom. Okay, cool. So something cool, right? Like the first time I saw this question way back when, my gut feeling was just like, okay, this is super easy. I'll just create the array. I'll create the array and then just go through it and do the XOR, right? But now I guess coming back to this a little bit later, it's a little bit more clear to me that we can probably get away without using the array or without creating the array and just sort of like using this to our advantage. Let's see what the discussion has to say. Oh, one time. Nice. It's gonna be some, yeah, this looks, I almost assumed, or not assumed, but trivial solution is the brute force approach and n space. Okay. 8, looking at these charts. Refine, code solution. This is wild. Yeah, constant space using this. Oh, I always love these. Easy. Yeah, I mean, when I see things like this, I'm like, okay, probably, I mean, unless this person's like a genius, maybe they just got it right away. Um, but then it also becomes a thing of like, okay, who actually solved it first, right? Like, let's say it was Coder 206. Like, are any of these solutions actually novel? Like, did they come up with it on their own, or are they just trying to like for example, you could argue like, oh, Coder 206, he has the highest rate of views, but he doesn't have like a description. So, hey, I want some brownie points. I'll just make my own post and say that I got it. But really, I'm just looking at Coder's thing, and then I'll just augment the description. It could be something like that. I'm not entirely sure. I'm just sort of like riffing here. But um, sorry, I had a thing I needed to get to here. But anyway, let's get back to it. So I'm happy with my solution. I feel like it's definitely at least, it's linear time. It's linear time with a constant space complexity. So I feel like that's definitely better than creating our array. Maybe I'll come back to it at some point to try and understand that bitwise manipulation stuff. But if I had to choose between getting really good at bitwise manipulation and getting good at like graph traversal, I'd probably choose the latter. Okay, cool. Decode the message is our next one. By the way, I'm gonna, and I need to be doing this right now, but I am keeping track of all the questions that we're working on. So we've done design and order stream and XOR operation. That way, when I upload it to YouTube, we can work on that. Okay, finally, a question of value. It seems we have stumbled upon. Okay, you are given the strings key and message, which represent a cipher key and a secret message, respectively. The steps to decode message are as follows. Use the first appearance of all 26 lowercase English letters in key as the order of the substitution table. Align the substitution table with the regular English alphabet. Each letter and message is then substituted using the table. Spaces are transformed themselves. So for example, given key equals happy boy, actual key would have at least one instance of each letter in the alphabet. Oh, so H is A is B, P is C. Return the decoded message. The quick brown fox. Oh, interesting. Let's think about this for a second here. I think really what I can do, I can almost be like a little, I think I could be a little greedy with this. I don't know if greedy is the right word, but like we can have not a count, but I guess a position. Imagine we have a position 0, and I'll start looking at Happy Boy, and I say, hey, have I seen H before? No, so I know it's going to be 0, and I'll increment my position. Now it's 1. Have I seen an A before? Nope. So I'll increment my position. I know that'll be 2. Have I seen P before? Increment. Have I seen P? Yep. Have I seen Y before? Nope. Have I seen B? Nope. Have I seen O? Nope. Have I seen Y? Yes. So I just need to map it once, and I can sort of use that as my alphabet. So let's start with this. What I'll do is I'll create something called an alphabet map. This time I'm going to create a map. I want to use like an actual ES6 map. Now let's see. Let's create our position. Do I need to, is there like a nicer way for me to go about this? Yeah, I think I'll need to create the position. So let position equals 0 for let I equals, I guess we can do for const C of key. So C is just the character. So we can say if alphabet map at C is equal to undefined, then alphabet map at C equals position plus plus, right? So if we haven't seen it, we'll set the position, increment it, haven't seen it. If we've seen it, we don't do anything, and we sort of continue going in this way. I think it said that space are transformed to themselves. Okay, cool. So let me remove some of this stuff now. I just want to do a quick console log to see what we have in our alphabet map here. And I just realized this is a map, so we really should make sure that we're using this correctly. So alphabet map dot has C. If it doesn't have C, right, we should set it equal to alphabet dot map dot set at C. We'll set position. So using some nicer syntax, this is one of those things that's good to know. Like using object literals is totally fine, but I think showing some, like having experience with, maps or sets in JavaScript will show a little more intuition of the language and some experience. That's always something good to use in programming interviews. So definitely something good. I'll probably start using that more often. So let's see, I want to go through all of I want to get the keys. Can I do an entries? Actually, let's look this up. So MDN map. How can I iterate through this? Instance methods, iteration methods, keys, values, and entries. Key value. Okay, so I think we can do for const key value. We use array destructuring of alphabet map dot entries. So let's just do console log key value. I just want to see what this gives me, just to make sure we're on the right track here. So the quick brown fox 0. So when do I get? Oh, well, these actually they're all represented at least once, right? This is a secret. And the 3, okay. So now, oh, and the 3, we should only assign, I don't think we need, or actually, I guess the space is fine. When I see a space, I can just add that. Now I think for my actual alphabet, there's a way that we can do this sort of like not really like in line, but this is going to be all lowercase letters, right? I think if I think of, I'm going to look at the ASCII table real quick. In the ASCII table, I think lowercase a is 97, is it? 97. Okay, so instead of having to create an array, what we can now do is we can say, let's say const decoded is a new array. Now we can go through the message. We have our key. How is it here? The key and then message. Taking the first appearance of each letter in the quick output. This is a secret. So T goes to V. Oh, so we're decoding it. Okay. So we're taking the message. So for const C of message. Okay, a couple things we need to do here. We want to get, let's see, if we could do like if C is equal to a space, we'll just do decoded dot push C else, right? So what do we have in message? We have our key values here, and this is going to give me, right? So I need to look up. So let's say const let car code equals. Here we should be able to do alphabet map dot get C. That's going to give me a number. And now if we do let car, I think we can do, this is going to be kind of interesting. String dot from car code at car code plus 97. If this looks crazy to you, I will explain. Return decoded dot join. I'm very curious to see what this does. Let's not take that out yet. Let me just comment this because that's going to be helpful for debugging. String dot from car code at string from car code. Okay, so it's just car code. Oh, I think I did it backwards maybe. Well, at least the positioning is correct. Let's see. Plus 97. So let me look at this one. Let me come here. I kind of wish I had, well, I just want to take one. Okay. So the message, if I get a V, I'm getting 20. 20 plus 97, it's 107 and 117. And 117 is U, which is not correct. So I mean this is correct. But let's see, I think I'm maybe just, so the T is 0. Oh, do I want to get alphabet map dot get message? I know I'm very close here. T is 0, so when I get to a T, I knew that we were a little bit closer, but is obtained by taking the first appearance of each letter, right? Now, are these always going to be 26? At least once. Okay. So for const C of key, T will be 0. When I get to the message, when I get to V, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16, 17, 19. What's 19 plus 97? 19, I should be able to do this in my head. Okay, 116. 116 is T. Oh, am I off by 1? QRSTU. Am I off by 1? Should it be 96? That seems weird. Getting closer, but that piece is a little bit strange. Maybe it would be better to just have, maybe instead of, you know what I should do? Instead of having like this should be my map, right? I shouldn't have, my map should be the key to what it represents. Yeah, I think that's what we'll do. So if it doesn't have C, then at C, I should set, yeah, there you go. And C not equal to space. I also feel like we shouldn't be adding spaces. I also feel like we shouldn't be adding spaces here. So let's do, if it doesn't have C and C is not equal to space, then why don't I just add, here I should get const car is string dot from car code at position plus 97, because 97 is that lowercase a. So I'll set the car here, and now let me comment all this out, because it will make it way easier if I just had a mapping of letters, right? T, A, B, C, L, G is Z. There you go. I think that's going to make it a lot easier. And I think really what we can do now is, can I do, this is coming in as, yeah, I think we could do for const C of message, pretty much the same thing here. Let me just uncomment this. Don't have to like copy all that over. Decode push, else, just decoded push get from alphabet map dot get C and return decoded join. This seems better. This is a secret. This is a secret. Okay, so let's now remove this console log here. Fantastic question, by the way. Very good question. This is like top tier question right here. Let's see what we got. And it's passing. Cool. Let me run this again so we can see what the time complexity is here. Really happy with this. I mean, this question is fun. This is like, if you're, oh, 69, 69, that's funny. If you're looking for like a good question that tests a lot of different things, this is the way to go. And I feel like, let me see. 'Cause it'd be nice to not even have to worry about this, but I suppose that's okay. Let's see what we have in discussion here. Java solution using hash map, original letters, space. Very cool. Yep. So I'm pretty happy with the solution. Let's talk about it a little bit here. So what's the time complexity, right? We're going to be looping both through key and message at different points. This is one thing I always forgot. Like, you have to pay attention to both key and message. Like key dot length is less than 2000. Uh, here, okay, so here the message is going to be, message and key dot length are both going to be the same. Now, if they had different bounds, like if message was 1000 and key was 2000, then we can say the time complexity is m plus n, right? Because we're going through key and then we're also going through message. But because both of these have the same upper bound, I think it's okay to say that it's O of n. Someone let me know if that's not a fair assumption to make. Maybe it's not, but I feel good about that. Here in our alphabet map, we have a new map that says all the letters at least once. You know what we could do instead of creating this map? I wonder, let's do something here. Can we just create a fixed size array where, let's see something. Let's do new array of 26 dot fill. I'll just, well, yeah, that's fine. Oh, although I know it's not, it's just filled with like undefined values. I know it's kind of strange to do that, but if you just do a new array at 26, I believe, and I've been looking at this for like, I've been looking at this a lot recently, but if you use the constructor, it tells you here, static methods, constructor, yeah, empty slots. You'll have empty slots, not actual undefined values. So I'm just going to set it to undefined to make it things a little easier. I think what I can do here for const C of key, what if here we get the index? So const index equals C dot car code at 0 minus 97. So car code at will return the ASCII value, and it's at the 0th index, which is, if you imagine this is a string, the 0th index, minus 97 to normalize it. This will give us the index. So if alphabet map at this index is equal to undefined and C not equal to space, then we can get the car, and then we can say, let's see, alphabet map at index is equal to car, position plus plus. And then here, if C is equal to that, else let's get the key again. And then we can say alphabet map, we want to get the thing at the index. Will this still work? Okay, so it looks like it's still working. And I feel like this should, oh, but you know what? It's going to contain every, well, let's see. So far, it looks like slightly better. It might be because if we think about creating a map, it's most likely going to be stored in the heap, whereas with an array, it can just be stored as like static memory, like in the stack. It's contiguous blocks of memory, so it's easy for the compiler, I guess, to optimize, right? So let's see what our times are looking like here. 47, 97. So I feel like there's definitely a difference in using this fixed size array here. So for anyone watching, definitely something to keep, if you see something like this, that's like, oh, lowercase English letters, it's like bounded by just the alphabet. It says at least once. So, we know it's only going to be of size 26. Go ahead and create that fixed size array. It'll save you on space. So now our space really effectively is O of 26, which is just constant. Maybe with the exception of decoded. I suppose that decoded, no, well, decoded also can only ever be consi of message. Well, I guess it can be the size of message. So maybe this is still bounded by message, but it saves us some time, which is always good. Very fun question. I'm going to like this question. It teaches it like you learn a lot from doing it. So highly, highly recommend going through it. Cool. Let's see what our next one is. Sum of all odd length subarrays. Oh man, this one's a doozy. I have never solved this question, so let's see if we can this time. So given an array of positive integers, return the sum of all possible odd length subarrays of R. A subarray is a contiguous subsequence of the array. So let's think about this. This one's going to be tricky, right? So when I first looked at this question, one of the things I did was I just started writing out all the numbers I see. So if we see like 1, 2, 3, 4, 5, we're going to see 1, 4, 2, 5, 3. But then you see the next group of 3 is 1, 4, 2. So we're going to see 1, 4, and then 2. And then we're going to see 4, 2, 5. And then we're going to see 2, 5, 3. And finally, we're going to see all these numbers once more. 4, 2, 5, 3. So this, like when I was doing this, I was looking at it and I was thinking, hey, look, there's a pattern, which kind of almost worked. But then let's see, like for 1 and 2, we only get 1 and 2, like 1, 2, and then 10, 11, 12. If we do this one, we'll get 10, 11, and 12. And then again, we'll get 10, 10, 11, and 12. So it's not like I feel like, oh, it's immediately clear what it can be. Um, I feel like it could almost be like, how do I figure out where like it's gonna start, if that makes any sense. Let me try to fiddle around with some of these lengths and we'll see. So like this is an odd length array, right? So odd length array, this is an even length array, and this is an odd length array. So if it's an odd length array, 0, 1, 2, 3, 4, If we do 5 divided by 2, that's going to give us a 3. Will I always visit, let me see, 5 divided by 2, like the highest one is 5. Each side starts at 3. Like, why would each side start at 3? I realize this could maybe be like a sliding window problem, but and there's probably like a brute force way of doing it. But I don't want to do it a brute force method. Hmm. Let's see if we can sort of see what the pattern is here. We have 5 and this one has 3. So when it has 3, like we're just bounded by this 2 here. What if I added, like what if we made another array? Let's make one that was even, but like 1, 2, 3, 4, 5, 6. So this is even. How many times will we see this? 1, 2, 3, 4, 5, 6. Then we'd have 1, 2, 3, 1, 2, 3, 2, 3, 4, 3, 4, 5, 3, 4, 5, 4, 5, 6, 4, 5, 6. And then we'd actually have 1, 2, 3, 4, 5, and 2, 3, 4, 5, 6. So sometimes hmm, this still started at 3. This started at 3. This started by 1. This started by 2. Why is that the case? I wonder if it's just like minus. No, it's definitely not length minus 1, how you start. What if we just do divided? No, divided by 2. Like 5 divided by 2, rounded up is 3. 6 divided by 2, that's an even 3. 2 divided by 2 is 0. Do we do math up floor plus 1? 3 divided by 2 is 1, plus 1 is 2. But we stay at 2 the whole way. This is the part that becomes a little bit annoying. We stay at 2 the whole way for this one. This one here, why is this one, why does this one not have like a peak? And why am I, like I keep focusing on this like notion of having 3 to begin with? The sum of all odd length subarrays. I wonder if like can like a prefix sum work here? Subarray is a contiguous subset of the array. Hmm. What else can we use to our advantage here? Like, would a hash table help us out? How can we like store, or if we, is this something that we can do like recursively? Like, first start looking, can solve like individual ones, and then sort of like look at a window. That doesn't seem too good though. If I have a window that's 5, yeah, 1, 2, 3, 4, 5, or 1, 4, 2, 5, 3. Odd length subarrays of R and their sums are. Can you solve this problem in O(n) time complexity? So that's actually a follow-up. So maybe I should try to think about a brute force method first before even trying this out. Which I guess like, can we just always? Oh, is there even a point to doing this anymore with Fang doing layoffs? Well, first I want to say I appreciate the question because I don't get enough questions on this, so I really do appreciate you asking. So I think like the way I see it is like me right now currently, I'm mostly doing this just to sharp like keep my problem solving skills sharp and also just to always be interview ready because they might be having layoffs now, but at some point in the future, hopefully that will stop and these companies will start hiring again. So if you're always prepared, then like you don't want to miss the next big wave, or companies are giving out crazy salaries or whatever bonuses they're getting. Like if you're not interview ready, you miss out on that wave. So better to just do like a couple of questions a day, keep your skills sharp, and then when all this blows over, which hopefully it will, you'll just be ready to interview, and then you'll just be like 1 foot ahead of everyone else. That's the way I see it, but I'd be curious to also hearing your thoughts. But thanks for asking the question. I really do appreciate it. Thanks for sticking around. This question is a little bit of a doozy here, because if we do, what if we had an array that, or a loop that did like all the ones first, and then we say, okay, for like now we're doing all the ones, then we do all the threes, and then we do all the fives. How would that look? Like I'm always gonna have, so if we do like, let's say we start at 1, if we do like for let I equals 0, I less than r dot length, I plus plus, for let, let's see, for let j equals I, j less than, I guess we would want to have, like this would, let's say this is hard coded first, j less than 1, j plus plus, j less than I plus 1, be something like this. This is like coming out to be some weird looking loop, but let's see what happens if we do 1, 4, 2, 5, 3. Because I want to do like all the ones first. So I will be here, and then j will be here. So j equals 1, j equals 0, j less than 1, it'll add 1, and that's it, it'll go out, and then we'll get to I, and then we're at I, j less than 1 plus 1, 2, we'll just add this one. Okay. And I guess we want to say this is 0. At some point, I'll want this whole thing to like reset again. But then I'll want for this to be 0, 1, 2, 3. All right, so I'll add 2 to this, and then I'll add 5 to this. 0, 1, 2, 3, 4, 5. So let's say let end index equal 1. We can say while end index is less than, what if we did while end index 0, 1, 2, 3, 4. If I did plus 2, that will give me a 3. If I did another plus 1, it will be a 3. And then I plus index at 5. So 0 plus 5, 2, 3, 4. I want to go up to 4. Yeah, I wouldn't want this to be, maybe instead of end index that I equals 0, I want to start at 1 every single time. Then I want to go up by 2. Let's see, r dot length. Kind of like stick this in here. Wait, no. This should be like this. This should be here. That'll be there. This is like a very weird method I'm trying here. But because I've never actually made it too far here, let's see. That's sum equals 0. What if we just did sum plus or equals r at j? But then how would this work here? J less than I plus n index. Just for like jokes, just for giggles, let's see what this does. This is like, didn't even like think about this. And it looks like we're oh yeah, of course I'm not doing this every single time. Return sum. Let's do an index plus or equals 2. Nan. Beautiful. That's awesome. I think I'm gonna move to my whiteboard real quick and I'll explain what I'm doing as I'm doing it. So I'm gonna start off by just writing out this first array here. So 1, 4, 2, 5, 3. 1, 4, 2, 5, 3. So I have like these windows that start at 1 and they increase by 2 every single time, right? We can have a window of 1, we can have a window of 3, we can have a window of 5, window of 7. These are all odd length windows of numbers that we want to get to sum. Like we want to sum numbers in those windows. So I can imagine that I'm started here at I and then my j. So I have an I at 0 and I also have a j at 0. And I can do like, let me see, for let I equal to 0, I less than nums dot length. Of course, I'm running out of ink on my marker. Nums dot length, nums, or I plus plus. Let's do this. I'm going to kind of keep the same pattern I had earlier. For let j equals I, j less than or equal to 1, just in the beginning to kind of get a sense for this. I want to do sum plus or equals nums at j. So let me see how this goes. So for let I equals 0, j equals I, j less than, let's do I plus 1, j less than I plus 1. Okay, so j less than 1. Is j less than 1? Yes, it's 0. So let's add the thing that's at that position. So it's going to give us 1, and we'll increment j plus plus. J is now 0 plus 1. It's 1. It's not less. We break out of that. And now we go to the next I, which is 1. J equals I, which is 1. We do 1 plus 1, 2. Now we just add that number. So that should get me all the way, right? I'm going to keep following this pattern. I'll get to the end. I'll say J. J is less than I plus 1. I'll add this one. I'll increment it. It's no longer less than I plus 1, so we can break out of this. So I think that first loop, j plus 1, is going to work out fine. 1, 4, 2, 5, 3. And now we should increment our index. Our index can now be this 3 here. So now I'm saying, okay, like the range at which I want to extend this window is always going to increase by an odd like amount, because that's like the length of my window, right? So now I'm going to go to 3 because I want to capture sums in windows of size 3. So now I'll say I plus 3 in that j loop, and we're going to start this whole thing again. So for let I equals 0, j equals I, j less than 0 plus 3, which is 3, 0, 1, 2, 3. We're here. We're going to now do sum 1 plus 4 plus 2. Okay, we're going to keep doing that. So I think that works fine. What happens when I get to 2? 0, 1, 0, 1, 2. I think j needs to be less than I plus 3, because here j is less than 0, 1, 2 plus 3. Yeah, and less than. So I think one thing I messed up here, I think this end index can work fine, but I should have another condition in here to say j is less than I plus index and j is less than nums or r dot length. Okay, so let's do that one. We'll add all those. So we'll say 0, 1, 2 I, j is 2, 2 plus j is less than 2 plus 3, 5, which it is, and j itself is less than r dot length. Okay, we'll increase it again to 5. J is less than I plus 5. Oh, let's see, when we get to 5, what happens if I say 0 and then j is less than I plus 5, 0 plus 5, that's 5, that's here, and now j is at the end. Okay, but I only want to do these once. I wouldn't want to also do it again, right? Let's see. 3, 1, 2, 3, 1, 2, 3. I think I also need to account for I is less than nums.length. And I feel like maybe I less than r.length and I plus n index is, let's see, 0 plus 5 would give us 5. Yeah, it would have to be I plus n index minus 1 is less than r.length. It's one of those questions now that is getting unwieldy. Like, I'm not ecstatic about this, but it can hopefully be a way that we can try and solve it. And then while end index is less than r.length, I guess, could we make it, if I do this, will that be okay? Let's see. Let's just mess with this now and see what we got. That's insane. Like, somehow that gave me the right answer. That's crazy. Now I really don't think this is the best way of doing it. Now, okay, so I just want to say something for everyone watching. There's 12 people watching right now. And I'm going to give a quick testimonial of this method that I'm following because I hope it will inspire some of you. So I started doing this like 4 days ago where I'm actually talking about what I'm working on and streaming it, which is like it helps me twofold, right? One of them, I get to talk about what I'm working on, which gets me to like really clarify my own thinking. And two, I'm under pressure because people are watching. So that's good just for like general interviewing. And I never solved this question before, even this brute force method. So I just want to say, like, for anyone out there that's struggling or think there's no hope, they're never going to get to land their dream job or they don't feel smart enough. I have totally been there, but I can tell you without a doubt that just in this, not even 1 week of doing this, I have absolutely improved. So I really encourage you to do the same thing and you will make progress and you'll get to wherever it is that you want to get. So, because I'm ecstatic about this right now. I don't even care that it's not the linear time complexity. I solved this and I came up with a way of doing it. Might not be the best, but I planned it out and I got it. So you can also do it. And just again, one more time, like I am going to upload this stream to my YouTube channel, which I have linked in the chat right now. If anyone wants to, like check out the YouTube channel, subscribe if you want to like get access to more videos as I keep making them. If you don't ever get a chance to watch them here on Reddit, highly encourage you to do the same. Here I have the LeetCode accountability stream number 1. I say, hey, start here because you can click on this video. You'll see all the links of the questions that we work on, which looks like YouTube's kind of frozen right now. Let me just refresh. You'll see all the questions that we've worked on. You can either work on them first and then watch the video, or you can watch the video while you're working on them. And if you start in the first one and just go all the way to where I am now in this 6th one, then you'll be able to have the amount of questions that we've solved, right? If you're sitting at 0 questions right now, you watch a couple of these videos and now all of a sudden you're at 34 with hopefully some more motivation and an accountability buddy. So I'm very happy about this. Let's see if we can maybe do one more. Coming up on the hour now. But this is like, oh man, I'm definitely, let me save this to my list of things to come back to because it's not optimal, but I would love to think about it, to think of how I can make it optimal. Cool. Find the center. Oh, okay, we're going to end off with a nice, easy one. Okay, there's an undirected star graph consisting of n nodes labeled from 1 to n. A star graph is a graph where there is one sensor node and exactly n minus 1 edges that connect the sensor node with every other node. is very simple, and unfortunately, I just know a very clever trick of solving this, which I'll share with you all right now. Like the center is going to be the number that's in every single one of these arrays. So it's going to be like one of these. Like you really just need access to both of these indices, and you say like, okay, is one in this array? No. If two is in this array, then that's it. That's really the answer. So let's see how we can like figure that out. Uh, let's see. If edges at 0 equals, or edges at 0, 0 equals edges at 1, 0, or edges at 0, so we want to check, yeah, 0, 0 equals edges at 1, 1. We can return edges at 0, 0. So let's just make sure, right? Like if 1 equals this one or this one, which it doesn't, forget it. Else we should just be able to return the next one. I don't think I've actually seen it like this myself, but 0, 1. Let's try it out here. Like if 1 is equal to this one, or it's equal to this one, 1, 1, return that one, or just return 0, 1. So that will also work. It'll give us 1. Not having premium, like I've been spoiled with premium to spam this run code button. 2, 1, 2, 1. 86.98. So I mean, this is constant space, constant time. You know, like when I first saw this question, I was trying to go crazy with it, trying to figure out how I was going to do it. But this is one of those just like clever things that you either know how to do it or you don't. But hopefully you got some intuition on this, that you just find the one that's in all the arrays, right? Because that's the one that has an edge to every other node. So a good thing to think about. Anyway, thank you all so much for tuning into the stream today. Had a lot of fun doing it today, just a little over an hour. Again, for anyone still watching, I will be uploading this to my YouTube channel. You can just find my YouTube channel. It's just my name, Rafael Negron, here on the screen. And I'll also, let me actually also, I'll put my name here on the chat so you guys can look it up. And you should also be able to find it based on just the title of the stream, like LeetCode Accountability Stream. That's what I'm calling it. So check it out. Do the questions. I would love to, hear the comments, see the comments, read the comments about your progress, and let us do it together. Thanks again to everyone who tuned in. I'll be here again tomorrow for stream number 7. So take it easy, guys. You guys all have a great one. Later.